intermediate code, we are having different formats. One of them is 3 address code. Coming to the 3 address code, so we have discussed how to represent expressions, how to represent control statements. Today we will see remaining parts, how to represent functions and how to represent input output format or input statements like. After that we will move to the quadruple representation. Then we will discuss about runtime environment. So coming to 3 address code, so suppose if you take any function, sum a comma b, parameter a, parameter b, call sum, comma to sum like. So this is the given function. So our question is how to represent this given function using 3 address code. How to represent the given function in 3 address code. So if any situation, if you get a function program or a part of the function, if you want to represent that in a 3 address code, first you need to take the parameters in the temporary variables. So here we are having 2 parameters, a comma b. So t1 equals to a, t2 equals to b. So I represented these two, or I assigned these two for the temporary variables. Suppose here sum of a comma b comma c is there. So then I will take one more temporary variable and I will assign that parameter to the temporary variable like that. So first we need to assign the given parameters to the temporary variables. After that, there are 2 parameters. One is parameter a, another one is parameter b. So that's why we need to take as it is. We need to take these 2 as it is. And this is also the same set. So parameter a, parameter b, call sum comma 2, call sum comma 2. So this is the 3 address representation or 3 address code for the given function. Here we need to add this part. This part is sufficient to add the given code. Remaining everything is same. So the assignment and everything both are same. Suppose if any function having, this is the statement like that. For this statement you need to write. Some temporary code or 3 address code. For that purpose, t1 is equals to b plus c, a equals to t1. So you need to add this part. So you already know about the expressions, how to convert the expressions into 3 address code we saw in the previous class. So this is the way to represent the given function into the 3 address code. Maximum you will get the questions on expressions. And suppose if the paper is difficulty, then you will get the questions on control statements. So from the functions, from input statements, they won't ask you the questions, but I am explaining you how to convert the function into 3 address code. Just I am explaining this. So you won't get the questions, and till now they didn't ask the questions from the functions and input statements like that. So suppose another one is input statement. Suppose if there is an input statement or output statement. So at that time, input or output statement, at that time, how to convert that into 3 address code, we need to see. Suppose the statement is printf, suppose compiler, comma, X. So this is the program statement. We need to convert this into intermediate code. That is nothing but 3 address code. Sir, how can we represent? How can we represent, sir? Initially, just take the constant value. What is the constant value? You need to place it, or you need to assign it with the temporary variable. Suppose T1 is equals to compiler, because this is the constant. It won't change, sir. It won't change. This is the constant value. First, we need to assign the constant value to the temporary variable. So that is the first step, sir. After that, we need to take that into the parameter. So what are the different kind of parameters are there? This is the one parameter and this is the second parameter. Sir, how can you say the parameters? Because this is the function. So inside the function, what can we have? So the parameters we can have. So here up to starting from the double quotations to double quotation end, that is the one parameter, and comma X is the another parameter. So we need to take the parameters. What are the parameters are there? So first parameter T1, and second parameter X. There are 2 parameters. After that, what we need to do? We need to call the function. Here the function name is printf. So call printf. Sir, how many number of parameters are there, sir? 2, sir. So here it is 2. Call printf 2. So here this is the name of the function. And this is the number of parameters, number of arguments are parameters in that function. So every time when we are writing about the functions, here also we have written call sum comma 2, because there are 2 parameters are there. A comma B. The function name is sum. So we are calling that function. That's why here we have taken call sum comma 2. Suppose if the parameters are 3, then we need to write call sum comma 3. Suppose the parameters are n, we need to write call sum comma n. So that is the way of representation of 3 address code for the functions and input output statements. For the input output statement, first we need to take what is the constant here. Here the constant is compiler. So we are assigning that constant to the temporary variable. After that, how many number of parameters are there? Yes, there are 2 parameters are there. One is compiler is one parameter, comma X is the another parameter. So parameters are 2, T1, X. Here compiler is taken into T1. That's why parameter is T1. Then we need to call the function. With name. What is the name of the function here, sir? Here the name of the function is printf. That's why I'm call function the comma number of parameters of the function. Here the 2 parameters are there, or 2 arguments are there. That's why I have added printf comma 2. 2, sir. So this is the way of representation of 3 address code for the given input output statement. For any input output statement, you can write it, sir. For any kind of input output statement, you can write them. So this is the way for writing 3 address code for the input output statements. So in GATE examination, till now they didn't ask the questions from this area, from the input functions or input output statements and functions. So majorly they will give the questions from the expressions. So expression evaluation, if you know how to evaluate the expression, you can answer the questions. You can answer the questions definitely. So most of the cases you will get the questions from the expressions. In the typical situation, or if the question paper is hard, then they will ask the questions from the control statements. In the previous class, we clearly mentioned, I clearly explained you how to write the 3 address code for the control statements also. Suppose for loop statement I have explained you, and for if statement I have explained you. So in the same manner, for while and all those things, you can write the 3 address code, sir. You can write the 3 address code by practicing the questions. So this is about the representation. Sorry, the representation of 3 address code. The representation of 3 address code. The next concept from the 3 address code is quadruple. The next concept from the 3 address code is quadruple. Sir, what is quadruple? Quadruple is nothing but it is having 4 tuples. It is having 4 tuples. 4 tuples. So we are calling that one as quadruple. So the name given because it is having 4 tuples. Sir, what is the purpose or what is the need of quadruple? So what is the need of quadruple? In quadruple notation, generated 3 address code arranged in array format. So this is nothing but, or quadruple is nothing but the array representation or the representation of array for the generated 3 address code. So we are generating 3 address code. Suppose, for example, if there is x is equals to a plus b star c. So the 3 address code for this is T1 equals to b star c and T2 equals to a plus T1 and x is equals to T2. So this is the 3 address code for the given expression. So the representation of this in some particular notation. So that notation is called as quadruple. Why we are calling this one as a quadruple? Because it is having 4 tuples. Tuple is nothing but columns, sir. Tuple is nothing but column. So 4 columns are there, sir. So the 4 columns are, one is result, another one is operator, and next 2 are operand 1, operand 2, sir. So this is nothing but quadruple representation of 3 address code. For this, we can write it as, here the result is in the T1. So that's why T1, operator is star. Here the operator is star, sir. So asterisk, and operand 1 is B, operand 2 is C. In the same manner, T2 operator is plus a t1, and here result is x, and operator is assignment operator equals to, and t2 is the operand 1, there is no operand 2. Sir, already in the starting classes clearly I mentioned you, 3 address code means at most 3 addresses. At most 3 addresses. That means one address may be allowed, 2 addresses may be allowed, and 3 addresses also allowed. Here 1, 2, 3. Here 1, 2, 3. Here 1 and 2. So based on the format of an expression or the evolution order, so that may have 2 addresses or 3 addresses like that. So this is nothing but quadruple representation. This is nothing but quadruple representation. Why we are calling that one as a quadruple? Because it is having 4 tuples. Tuple is nothing but columns. Tuple is nothing but columns. So here 1, 2, 3, 4. 4 columns are there, sir. That's why we are calling that one as quadruple. What it will do? So quadruple represent, or that is the standard notation of generated 3 address code. Here we generated the 3 address code for the given expression. So that is having some notation or some standard format. That is nothing but quadruple. That is nothing but quadruple. So here one previously asked gate question is there, sir, from the quadruple. We will see that. After that, we will move to the next concept. Before going to that, please write it. Consider the following 3 address code table. Operation operand 1, operand 2, result. Hyphen C T1. It's not a hyphen, sir. It is a subtraction operator. That is also called as hyphen. So multiplication B T1 T2 plus A T2 T3 and move T3 A. So this is the table given, sir. This is the table given, and he is asking which of the following expressions, represents the above 3 address code. Above 3 address code, simply in bracket quadruple notation. The options are option A. A equals to A star B plus minus C. Option B, C equals to A star B plus C. Option C, A equals to A plus B star hyphen C. And option D, C equals to A plus B star C. So this is the given question, sir. This is the given question. So for this, what is the correct representation, or which is the expression represents the following 3 address code table? So the table is given and the notations are there. So what is the correct notation or correct expression? So we will see it, sir. We will see it. So initially resultant is T1 equals to operand 1 and operator is there. That is nothing but simply we can say that minus C. Minus C is assigning to the T1. Minus C is assigning to the T1. After that, T2, the resultant is T2 equals to T1, B. What is the operation? Operation is multiplication, sir. Here this is an operation. So operation is multiplication, and second operand is T1. Second operand is T1. After that, T3 equals to A. What is the operator? Plus, and the second operand T2. Then move is nothing but assigning. So here the resultant is A, and we are moving the value T3 to A. So that is T3. So simply here it is specifying the thing. A is the resultant. So in this option there is A. In this option there is A. Here this is C. There is no option A, and here there is no option A in the resultant. So that's why I am eliminating these two. Because they, here we are storing the resulting in the C. Here we are placing the resulting in C. C is nothing but T1. But here T3 is nothing but A, sir. So total result is in the T3. In that case, in that situation, I am eliminating these two. I am eliminating B and D, sir. So now if we check this first one. So first thing is we are assigning minus C to T1. Okay. T1. So this is okay. After that, we need to calculate A into B. So here we are multiplying B with T1. In T1, what is the value? C is there, sir. But here the multiplication operation need to be performed A into B, or A and B. So but here we are performing on B and T1. T1 is nothing but C. That's why if you see here, B and C1 multiplication operation is performing. After the resultant is in T2. T2 is adding to the A. And the result is moving to again A. That's why option C is the correct answer. Sir. So the questions are very simple, sir, from 3 address code. So for the 3 address code, they will give some expression and they will ask the 3 address code, or in some situations they will give some 3 address code and they will ask you to write the expression like so. And another one is coming to here, how to represent the quadruple for the given expression, they may ask. And sometimes quadruple they may give the input or the as a question, and they will ask you what is the expression for this quadruple. Like they may ask you, sir. So this is the topic about quadruple. Here we are having some disadvantage. In quadruple, there is some drawback. What is that drawback? What is that drawback? You see here, sir. You see here. Sir, suppose if we see the result, in the result, some temporary variables are there and some permanent variables are there. Here, A is the permanent variable because that is in the program or that is in the expression. But T1, T2, T3 are just temporary variables we are using for calculating or for evaluating the expression. But those are not required after completion of the calculation or evaluation. But here the compiler stores these temporary variables in the symbol table. So the temporary variables are also placing in the symbol table. So by placing the temporary variables in the symbol table, the memory wastage will be occur, or the wastage of the memory will occur. So that is the drawback of quadruple. In the quadruple, there is a drawback, that is here in the result, tuple or result column, some temporary and permanent variables are there. Those temporary variables are also, you can write it as non-terminals. Those temporary variables also placing in the symbol table. So that is the drawback, sir. So what is the remedy for this, sir? Or what is the solution for this? What is the solution for this is, we are using triple. In the place of quadruple. By using quadruple, so the representation is very good and the understanding is also very nice. But the difficulty is there, or the drawback is there. What is the drawback? The drawback in this or in the quadruple is the temporary variables are also storing in the symbol table. So that is the drawback. That is the drawback of the quadruple. So that's why we are moving to triple. So what is triple? How we represent the same thing in the triple. In triple notation, like as a quadruple, this is the triple. Triple means 3 columns or 3 tuples. The use of, in the triple notation, the use of temporary variables is avoided by referencing the pointers. So we'll see it, sir. Suppose the same example if we take, or else another example if we take, operand 1, sorry, operator, operand 1, operand 2. Here the operator is asterisk B, C, and operator is plus A, and here I am using the pointer or the address as 100. So the same address I am using here. And next one is equals to 104, comma X. Suppose if we see here, first of all, we are having 3 columns, 1, 2, 3. So in the previous example, we are having 4th column, that is the resultant column. In the resultant column, we are having some temporary variables. For those temporary variables also, that is also assigning the symbol table memory. So that is the disadvantage of the quadruple. For that purpose, here we are using pointers. This is the pointer of this total expression. The total resultant is pointing to the 100. So that resultant is we are using here. That's why I'm writing the 100 here. After that, for this total referencing, or that this total expression is referencing to the 104. So after completion of this, that 104 is I am using here, sir. So this is the way of representing the triple representation. In quadruple there are 4 columns or 4 tuples. In the triple there are 3 columns or 3 tuples. We are not using resultant column because in the resultant column we may have some temporary variables. For those temporary variables also, the symbol table is assigning the memory. So that is the difficulty. Sir, is there any difficulty in the triple? Yes, there is a difficulty. What is that difficulty, sir? Here we are using array representation, or we are using array for representing this notation. So array is nothing but the static representation. So for that purpose, to overcome that problem, we are moving to indirect triple. Indirect triple is representing with the help of list. So the list representation is overcoming the problem which is in the array. The list representation can overcome the problem which is in the array. So that is the things. So you may get the some theoretical question like, so what is the problem with the quadruple, or what is the problem with the triple, or what is the problem with the how we are overcoming the problem with the triple, or how we are overcoming the problem with the quadruple, like also you may get the question from this. So this is about 3 address code. So till now we have discussed about intermediate code generation. There are different ways to represent intermediate code. That is nothing but so 3 address code and parse tree. So these are the different syntax tree and 3 address code and all these things. So we have discussed everyone how to represent, and majorly DAG. So one is syntax tree representation, another one is DAG, another one is 3 address code. So here there is a disadvantage. Common sub expressions are allowed. By removing the common sub expressions, we are moved to the DAG representation. So, but if we take syntax tree and DAG, these two are helpful to represent only the expressions. Those are unable to represent in in the intermediate code format for the variable declarations and input statements and control statements, functions, and all these things. Suppose if you take three address code, this is the one of the intermediate code generation or intermediate code representation. With this, we can represent expressions, arrays, functions, control statements, and all input output statements also we can represent in the three address code. So the some notation or some table representation of the three address code is nothing but quadruple. In the quadruple also there is a disadvantage. What is that disadvantage? So the resultant tuple or the resultant column having some temporary variables. For those temporary variables also in the symbol table, the memory assignment is going to perform. So that is the one of the drawback, because there is no requirement of memory for the temporary variables. So for that purpose, we are moved to the triple. In the triple, we are not using fourth column, that is the resultant column. Just we are using pointers where the resultant is mapped or attached. So here also there is some disadvantage. That is nothing but here we are using arrays. Arrays is nothing but a static representation. For that purpose, for moving to the next level, we are moving to the indirect triple. Indirect triple is using lists. Indirect triple is using lists. So this is about intermediate code generation, sir. So from these intermediate code generation formats and ways, if you are having any doubts regarding intermediate code generation, you can ask, sir. From intermediate code generation, if you are any one of you are having doubts, you can ask. Okay, sir. If you don't have any doubts, I will move to the next concept. The next concept is runtime environment. Runtime environment. So this is the next concept, sir. After this, we will have a small concept that is a 1 hour concept, that is nothing but code optimization. So if you finish these two concepts, compile design course regarding gate, so we'll complete, sir. So we'll see it. What is a runtime environment? What is runtime environment? If you see, suppose initially, if you take high level language, so that high level language is given to the initially that will be given to preprocessor. So after completion of the preprocessor, so we'll get the preprocessed high level language. Preprocessed high level language. That preprocessed high level language is given to the compiler. That preprocessed high level language is given to the compiler. Compiler will produce assembly language. Most of the cases, it will produce assembly language. This assembly language is given to the assembler. This assembly language is given to the assembler. And this assembler gives us a relocatable machine code. Relocatable machine code. The relocatable machine code. That relocatable machine code will be given to the linkers and loaders. Linker and loader. So for linker and loader, the relocatable code is instruction after linker loader. So the code will be sent to the code will generate, sorry, the linker and the loader generate the machine code. The linker and loader will generate the machine code. Machine code. That is nothing but low level language. So simply if we see here, we are starting with high level language. After completion of the preprocessor, it is giving the pre-processed high level language. So that pre-processed high level language is passing to the compiler. After completion of the compilation, it is producing assembly language. That assembly language is given to the assembler. Assembler will give relocatable machine code. That relocatable machine code is giving to the linker and loader. Linker and loader is producing the machine code. After the phase of the linkers and loaders, it will give the machine code. Okay, good. So my question here is, here the compiler process is completing. Here the compiler process is completing. So everything, identification of tokens, construction of syntax tree, construction of annotated syntax tree, construction of intermediate code format, and converting the assembly language. Everything is completing. Sir, what is this runtime environment? Runtime environment is nothing but at the time of program execution. Program execution. So is there link to the compiler with runtime environment? Yes, there is some connectivity to the runtime environment to the compiler. So we need to discuss what kind of environment or what type of connectivity the compiler having at the time of runtime. So the compilation is nothing but converting one form of data into another form of data. Along with that, it will return any errors in the our program or in the given program or in the written program, right? So that is completed. So even after that, it is having the connectivity or the having some activity at the time of runtime. At the time of runtime. So now we need to see is what kind of activity it will perform. What kind of activity it will perform at the time of runtime. Compiler takes care of the time regarding at runtime also, or it will take care of the code execution at the time of runtime also. How it will involve? How it will involve? It will involve in the scope of memory. In the scope of memory. So in this area, the compiler will involve. The compiler will involve for allocating and deallocation of memory. Allocation and deallocation of memory. Suppose if we see compiler subdivide the runtime memory into 4 different categories. This is the runtime memory. For example, if you take this is the runtime memory. This runtime memory is divided into 4 different types. One is code area, and the second one is data area, and the third one is stack area, fourth one is heap area. It will be done with the help of operating system. So compiler, operating system will assign some memory for executing the program, that memory will be subdivided into 4 parts. Those 4 parts are heap area, stack area, and data area, code area. So in the code area, we will store the machine code. We will store the machine code. What is the machine code, sir? Here there is a machine code. So this machine code will be placed in the code area. This machine code will be placed in the code area. And data area, it will have global variables. Global variables. It will have global variables. So, and coming to the stack, so stack can contain the activation records. Activation record. Sir, what is activation record? I will explain you. Just you please remember it. What is the allocation for the stack area? The stack area can be allocated, or it can be whole activation records. And coming to the heap area, it can hold dynamic data structures. Dynamic data structures. So like this, the total memory is divided into 4 parts. This can be simply, we can say that modern compiler will divide the given memory into subparts. But coming to the older compiler, so our old compiler, so in this there is no subparts. This is the runtime memory, and this is the program. If the program needs, our program size is 4 MB, the runtime memory is also allocated only for the 4 MB. Okay, here the size of the program is 4 MB, so the allocated memory is also 4 MB, so that is sufficient for execution. Okay, but in some cases, for executing, some extra memory will be required. For all the programs, the memory requirement for executing that programs is not same. For example, if you take recursive programs or recursive functions, can't execute with this older type, because recursion means same function can be called many number of times until the condition fails or until the condition met. Suppose if you take in a reverse manner, the condition need to be failed. Suppose if you take a positive manner, condition to be met. So like that. For recursive calls, we don't know how many number of times need to be called. So for that purpose, every time when we call the function, we need to store or we need to create activation record for that. So for that activation record, we need some memory. So here the memory is fixed. We can call it as static memory allocation. With this static memory allocation or with this static memory, so we can't increase it or we can't change it. That's why we cannot execute the recursive functions. Or sometimes it is maybe difficult. So that is the one thing. Another one is sometimes we need dynamic data structures. Dynamic data structures. With this older compiler, we can't create dynamic data structure. We can't create dynamic data structure. That's why we are moved to. That's why we are moved to this modern compiler. In this modern compiler dividing or subdividing the runtime memory into different parts. So we have some clarity on this. In the code area, we are having machine code. In the data area, we are having the global variables. And in the heap area, we are placing the dynamic data structures. And stack area, we are placing the activation records. So we know about the machine code. Machine code is nothing but the code which is in the here or in this part, that is nothing but machine code. Sir, what is global variables? For example, main int x printf percentage d comma x like, and take some function called f printf percentage d comma x like. Is it sufficient for us? Here in the main function we are calling f. In the function f we are displaying x. Here x is the local variable of main function. Suppose if we take int x, this is called global variable. And this is called as local variables. These kind of variables can hold in the data area. These kind of variables can hold in the data area. What kind of variables it can hold? Global variables. So this is a local variable and this is the global variable. So everyone knows about it, because in the every programming language we learn what is a global variable, what is the local variable, like that. So I think you understand it. Okay, next one is stack area. So this is the thing we need to concentrate on it, sir. So how the stack allocation can be done? Stack allocation. So here it is very simple. What is very simple? Code data. If any global variables are there, that can be held in the data area. Suppose the machine code is placed in here. So here our major concentration is at the stack area. Because the function calls are different and the number of times of calling of the functions also different. Maybe different. That's why we need to concentrate on here, sir. So the thing is for every function call, activation record is created. And pushed into stack. And second point also I'm telling, sir. So, and second point is function returns a value activation record is popped out, is popped out. Suppose at the time of stack allocation or in the stack allocation, when the function call for every function call, not for every function, sir, for every function call. Suppose there is a function, I call this function one time, activation record is created, and I am calling second time, again activation record will have created. Third time, again activation record will create. Fourth time, activation record. So for the same function, 4 activations are there, or 4 activation records are there. Why, sir? Because that function called for many number of times. That's why every function call, for every function call, activation record will be created. And for every function return, that means after completion of the execution of the function, it returns something. At that time, the activation record popped out from the stack. At the time of function call, it will push into the stack, and after completion of the execution of the function, at the time of returning the function value, it will pop out from the stack. Suppose if you see here, sir. Yes, sir. Suppose if there are some functions, main function is there, function A is there, function B is there, function C is there, sir. So in all these cases, suppose if you first, at the time of main function, main activation record is created. And for A, activation record is created. For B, some activation created. For C, some activation record is created, sir. So for function call, when I am calling main, activation record will create. For I am calling A, B, C, at particular times, the activation records for those function calls also created, sir. Now the thing is, when the function execution completed and it returns its value, suppose C completed, it will be removed from the stack. It will be removed from the stack. Sir, I clearly mentioned you, the stack area can hold, activation record. Activation record. At the time of function call, activation record can be pushed. At the time of function call, activation record can be pushed. At the time of function return, the activation record can be removed or popped from the stack. Suppose if we see what is activation record, what it will hold, we will see it, sir. What is activation record? But for the stack allocation, I explained you, sir. So activation record can be allocated, or activation record can be popped. Activation record can be pushed and popped. When the function call, it will be pushed, and at the time of function return, it will popped. Okay, good. So now the thing is, what are the fields? What are the fields in the activation record? What are the fields in the activation record? We will see it, sir. First thing is return address. Second is actual parameters. And third one is local variables. And fourth one is control link. Next one is access link. Saved machine status. So this is nothing but activation record, sir. Activation record. It holds all this data. Activation record holds all this data. So what is the data for every function call? It holds this data. Suppose if f is there, f is calling for 3 times, 1, 2, 3. For the first activation record, all these fields are there. For the second time call, these all, and for third time, all these fields will have. So now we need to see is what is the saved machine status, what is the purpose of access link, what is the purpose of control link, and what is the purpose of local values or local variables, and what is the actual parameters and return values. So these three are, we may have some idea. What is return address? Return address is nothing but after completion of the execution of the function, it returns something that is nothing but return address. That is nothing but return address. Actual parameters. There are two kind of parameters are there, sir. Actual parameters and formal parameters. So in the calling function, we will have the parameters. Those parameters are called as actual parameters. Local variables. So I clearly explained you what is the local variables. So these are called as local variables. These are called as local variables. And now we need to discuss about what is a control link, what is the access link, what is the saved machine state. Saved machine state. So for every function call, activation record is created, sir. For everyone, the activation record is created. Suppose if we see saved machine status, saved machine status. Sir, at the time of main function calling, the status of machine is different. Suppose after entering into the main, if there is some other function B, and suppose some other function B and some other function C, so after calling A, machine status is different. After calling B, machine status is different. After calling C, the machine status is different. For every function call, before function call and after function call and after completion of the call, the machine status is different. That will be hold. What is the status of the machine? Is hold in this field. That is nothing but saved machine status. Simply we can write the program counter work. This is the work of the program counter. That is nothing but that is the work of the program counter. Every time the program counter holds the address of the next executable statement. So like that only here also, what is the functions completed or what are the functions going to be executed, like that it needs to be holded, sir. It needs to be holded. So the saved machine status will have the machine status before calling the functions, after calling the functions, and after executing the functions, and at the time of executing the functions, In all these cases and in all these situations, what is the machine status will hold in the saved machine status. And coming to the access link, access link points to global variables. Access point or access link having the pointer to the global variables. Sir, what is the requirement or what is the need to having this access link? For example, if you say some example, main, suppose there is a program main int x equals to 10, some function is there or some function call is there, that is nothing but f printf percentage d x. So already we saw this example. Here, main function is there. X is assigning value to the 10, 10 is assigning to the x. And here we are calling this function. So our control move to the function f. Suppose if you see here, you need to print x. So x is the local variable here. So that's why this function, at the time of calling this function, it needs to connect with the global variables. It needs to connect with the global variables. So that's why we need some link to connect with the local variable. Sorry, local variables means it knows what are the local variables it will have. Every function knows, because the variables which are declared inside the function is called as local variables, and the variables which are declared outside the function is called as global variables. So it knows about the local variables, but it does not knows about the global variables. For that situations, or in that situations, to connect with the global variables, it needs to connect with the global variables, it needs some link. That link is called as access link. That link is called as access link. So access link will help. Access link will help to point to the global variables. So that is the purpose of the access link. That is the purpose of the access links. Another one is control link. Another one is control link. It points to activation record of calling function. It points to activation record of calling function. It is having the pointing to the activation record of calling point. Suppose if we see the main function is calling function big. Function big. So this activation record control link having the address of calling function. That means the main function. In the B, there is an activation record. In that activation record, there is a control link. The control link having the address of the activation record of the main function, because that is the calling function of B. That is the calling function of B. That's why control link points the activation record of calling function. The activation record of calling function. So this is about the activation record. This is about activation record. So you may get the very simple questions like, so one is how many number of activation records are there in the following construct. For example, main sum A. So this is one construct, sir. For example, main sum A, B, and A and B, it is calling C. So how many number of activations records? Activation record is nothing but calling of the function. Here we call main function once. After calling main function, we call another function that is called as A. So two function calls are there, sir. That's why two activation records. Two activation records. Here we call main function 1. After calling the main function, in the main function we are calling A 2, and after that A we are calling B, and B is the third activation record, and after that in B there is another call function call, that is C, and here that is. So finally 4 number of activation records are there, sir. 4 number of activation records are there. So activation record is nothing but that holds the different fields. Those are return address, actual parameters, local variables, access link, control link, and saved machine status. These are the things, sir. So by using access link, static scoping is performed. Static scoping. Why we are calling that one as a static scoping? Because access link having the pointer to the global variables. So that's why static scoping will be performed. By using the control link, dynamic scoping is performed. Here you may get the question, sir. You just note down. By using access link, static scoping is performed in programming languages. And coming to the by using control link, dynamic scoping is performed. Dynamic scoping is performed, sir. With static scoping, with access link, static scoping will be performed, and with the control link, dynamic scoping will perform. And coming to saved machine status, it contains the information saved machine code. Suppose if we see saved machine code, saved machine status, we see here it contains the information regarding status of the machine, before a function call. What is the status of the machine? Will be in the saved machine status. So these are the purposes of access link, control link, and saved machine status. So this is about activation records, sir. So from these activation records and from this runtime environment, we have some previously asked questions, sir. So we'll see those questions. After that, we'll move to the next code optimization. Then, so we'll see the questions, sir. So previously asked questions from this topic. So here I explained you what is the runtime environment. What is the need of runtime environment? What is runtime environment, like that? So runtime environment, at the time of runtime environment also, the compiler portion or the compiler requirement is there. So how it will be requirement for runtime memory? For the runtime memory will be in the modern compilers, it will be subdivided. It will be subdivided into 4 categories: heap area, stack area, data area, code area. Code area can hold the machine code. Data area can hold the global variables. And stack area can hold the activation records. In the activation records, there is a local variables also. And coming to the heap area, that can hold the dynamic data structures. So, and coming to the activation record, there are runtime address, actual parameters, local parameters, control link, access link, and saved machine status. These are all things are in the activation record. So in the activation record, the major things are access link, control link, and saved machine. Coming to the access link, it points to the global variables and it performs the static scoping in the programming language. And coming to the control link, it will be helpful to the dynamic scoping, for performing of dynamic scoping. And saved machine means saved machine status means it will holds the status of the machine before function call. So these are the things. So if we see the problems, previously asked problems, which language from this topic you will get the questions theoretically, sir. No need to do some calculations and all. Just some theory is enough. Suppose if you understand the class, you can directly answer the questions. Which language necessarily need heap allocation in the runtime environment? In the runtime environment. In the runtime environment. Option A, those that support recursion. And second one is those that use dynamic scoping. And coming to third one, those that allow dynamic data structures. And option D, those that use global variables. So this is the question, sir. This is the previously asked question. So theoretically you will get the question, sir, from these. So here the question is, which language necessarily need heap allocation? Heap allocation means, so we saw what are the different portions are there. So the different portions are heap allocation and stack allocation and data area and code area. So coming to the code area and data area, code area means machine code, sir. That is for every language or for every program that is required. And coming to the data area is nothing but for representing global variables. For any language, if you see, Local variables and global variables are common. So for that purpose, that is also mandatory. That is also for mandatory. And coming to the stack area, if at least one function will be exist for any language, C, Java, C++, and all these things. For that purpose, that is also required. And coming to the heap area, that is required only if the dynamic data structures are there. Dynamic data structures are there. For those languages only, heap area is required. So, okay, that's why we will check it. So in this question, he is mentioning those that support recursion. So recursion means functions. Recursion means function. So functions are related to the stack area because functions are called in the stack area. So for that purpose, activation records are required. So that is not required. So heap allocation is not required for this one. So that's why this is not mandatory. Those that use dynamic scoping. Dynamic scoping is nothing but access link. Access link is related to the activation record. Activation record is also related to the stack area. So that is also not a problem. And those that use global variables. Global variables means data area. So that is also not required. And those that allow dynamic data structures. Some programming languages allow dynamic data structures and some programming languages does not allow dynamic data structures. Suppose if we see Fortran, it does not allow dynamic data structures. That is not required. So heap allocation is not required because that won't allow dynamic data structures. So that's why here the languages necessarily allow dynamic data structures. For those only heap allocation will be required. For those only heap allocation will required or it is needed. It is needed. The option is those that allow dynamic data structures. Those that allow dynamic data structures. So that is the answer, sir, for the question. And one more question, if you see, which one of the following is not performed during the compilation. So this is also previously gate question, sir. So option A, dynamic memory allocation. And option B, type checking. Option C, symbol table management. And option D, inline expression. Which one of the following is not performed during the compilation? So we are having different pages: lexical analysis, syntax analysis, semantic analysis, intermediate code generation, and code optimization and code generation. So type checking will be performed in the semantic analysis, and symbol table management for every phase, symbol table management will be performed. So these two are clear. So this is not. What is dynamic memory allocation? What is inline expression? Sir, this is not, I didn't mention you what is inline expression. So inline expression is the topic about the code optimization, sir. So in the next class, I will explain you code optimization. So code optimization is also one of the phase. So these three are belongs to compilation. These three are belongs to compilation. Dynamic allocation or dynamic memory allocation means memory allocated at the time of runtime. Memory allocated at the time of runtime, not at the compilation time. That means that is not performed at the compilation. During the compilation, dynamic memory allocation is not performed. So the answer is dynamic memory allocation. You may get confused. You may get confused. Dynamic data structure is different. Dynamic data structure is different, and heap allocation is or heap area. Heap area is different. Heap area means dynamic data structure data will be held at the heap area, but that cannot, or compiler that itself cannot allocate the dynamic memory. It cannot allocate itself the memory. So that is about dynamic memory allocation, sir. So dynamic memory allocation is not performed during the compilation. So this is the answer. This is the answer, sir. So, and one more gate question, sir. One more gate question. So this is the last question, sir. Question. The optional access link, very simple, sir. With the discussed points, you can answer simply. You can answer it. The optional access link in the activation record is used for option A. Option A, pointing to the activation record. Pointing to the activation record of the caller. And option B, referring the non-local data. Referring the non-local data. And option C, temporary values. Temporary values such as arising in the evolution of expression. Option D, none. Option D, none. Very simple, sir, and very easily you can answer with the help of what is activation record itself. So what he is explaining and what he is asking, sorry, access link in the activation record is used for, what is the purpose of access link? Pointing to the global variables. What is the purpose of the control link? Pointing to the activation record of calling function. So the options are pointing to the activation record of caller function. So that is nothing but this is the link, control link. This is the purpose of control link. And coming to the temporary values such as arising in the evolution of the expression. So those are belongs to local variables and temporary variables and all these things. So that is not belongs to this one access link. So this is also not belongs. And coming to the referring to the non-local data. Non-local data are also called as global variables or global data. Referring is nothing but pointing the global variables or pointing the global data. Pointing the global variables or pointing the global data. So option B is the correct answer, sir. Option B is the correct answer. So from this area, from the runtime environment area, you will get the questions of theoretically. So the theoretical questions, to answer the theoretical questions, suppose if you understand the topic, you will easily answer the questions, sir. So no need to do calculations and all these things. You just what is the runtime environment, what is the activation record, what are the categories of subdivided runtime memory, and which part holds which type of data or which kind of data, and what in the access in the activation record there are some fields. What is the purpose of the saved machine codes, saved machine status, and what is the purpose of the access link, and what is the purpose of the control link, and what is the purpose of the local variables part, and what is the purpose of the records return address, and all these things. So if you have idea on that and if you understand the topic, you can easily answer the questions from this area, sir. So this is about runtime environment, and we are having a small concept, sir, that is code optimization. That is the 1 hour concept. In the tomorrow class, I will explain that concept, code optimization. After that, we have the questionnaires. So if any doubts are there regarding comparison from the starting class itself, you can ask any question. So you can ask any doubt. So I will clear those doubts in the tomorrow's class. In the tomorrow's class, we are going to finish the comparative design gate syllabus, sir. That's why you can ask the questions if you are having any doubts regarding comparison from the starting class itself, sir. You can ask any doubt. So from parsing or from lexical analysis and intermediate code generation and different kind of passes are there. So bottom up parsing, top down parsing. If any doubts are there, you please write it and you please ask in the tomorrow's class, sir. Thank you. I'm closing this session for today. Thank you.